All right, as promised, second example. This one is actually not more difficult, but it looks harder because of the 1 over x. But we don't treat this any differently. We treat it exactly the same. We just raise it to whatever power we need to in the expansion. So I'm pretty sure that the row of Pascal's triangle I would use here would be 1, 5, 10, 10, 5, 1. That's the same one from before. So it just makes it a little easier. I don't have to worry about the c's if I do it this way. Like I said, because this number is fairly small, I can still do this. This number was like 22. I wouldn't want to have to worry about doing these. I just want to use the c's. I would never make you do a full expansion that big, but I will ask you for a certain term in that expansion, so you're going to have to be able to do that. So starting off, first part of this thing, remember each one of these terms has 3 parts: coefficient, power of the first thing, power of the second thing. My first coefficient is 1. My first power of this is 5, so it's 1 over x to the 5th. My first power of this is always 0, y to the 0. And now I'm going to keep increasing the power here by 1, and keep decreasing the power, decreasing this by 1 and increasing that by 1, and just adding the coefficients. This one, because there's no numbers here, is a lot easier. I don't have to worry about, this isn't 2y to the 5th, it's just y to the 5th. Also, since this is a plus, I know that all these symbols are going to be pluses. Second coefficient is 5. Next power of 1 over x is to the 4th. And then I got y to the 1st, plus 10. Next power of 1 over x is 3, y squared, 10. Next power of 1 over x is 2, 1 over x. Next power of y is 3. I got a 5, and then I got 1 over x to the 1st, and then y to the 4th. And then last but not least, 1 over x to the 0, y to the 5th. Some of you might be like, do I have to keep writing 1 over x to the 0? The answer is not really, but it helps keep track of things. So the first term here, if I simplify, 1 over x to the 5th. I can write that like this if I want to. 1 to the 5th is just 1, so I can keep doing that. Plus, the only number here, the only coefficient is 5, so don't have to worry about that. I'm going to have y and 1 over x to the 4th. So I'll write this twice, times 1 over x to the 4th times y, plus 10 times 1 over x cubed times y squared, plus 10 times 1 over x squared times y cubed, plus 5 times 1 over x times y to the 4th, plus this last term is a 1 and a 1 and just a y to the 5th. And I think that it would be preferable if you guys would write these things as single terms. So this is 1 over x to the 5th. This one, though, is 5, like it's 5 over 1 and y over 1, so I can write both of these on top of this fraction. 5y over x to the 4th plus 10y squared over x cubed. 10y cubed over x squared. 5y to the 4th over x, and then y to the 5th. So this is your kind of your final answer. It's all simplified. Everything's put together. No common factors, top and bottom. This is a 2. That's really a poorly done 2. But there's like a lot of just some things to notice here, right? You got the powers of x decreasing by 1, which you expected. Powers of y increasing by 1, which you also expected. The coefficients, in this case, show up exactly as they do in the triangle, 1, 5, 10, 10, 5, 1. And that's because there's no coefficients on either 1 over x or y. So these last 2 examples to me are about as difficult as I would give you one on the test as far as expanding the whole thing out. I've never asked you to do one bigger than 5, I don't think, for the whole thing. So as far as memorizing rows of Pascal's triangle or writing them on your test or whatever, I mean, you can, since you get to use your notes, you can make as big a one as you want. But I will ask you to find me terms of expansions bigger than this, and we'll talk about that next week or in the next class. So I hope this was helpful.